Good day everyone, I am Sanliker Humantoclantad and I will be continuing the report of Chapter 5. This is the part 4 by the way. Chapter 5 is entitled Utilization of Assessment Data. Properties of variance and standard deviation. So the variance and standard deviation is the most commonly used measures of variation, most especially in research. And it shows variation of the individual scores about the mean. Then next is the relative measures of variation. Now, what is coefficient of variation? So coefficient of variation shows variation relative to the mean. It is used to compare two or more groups of distribution of scores, usually expressed in percent. And the smaller the value of the coefficient of variation, the more homogeneous the score in that particular group. It means pag sinabi nating homogeneous, ito yung parang magkakalapit lang yung score ng isang group. And the higher the value of the coefficient of variation, the more dispersed the scores in that particular group. Pag sinabi naman nating dispersed, parang magkakalayo yung difference ng scores in that particular group. So the formula in computing the coefficient of variation is coefficient of variation is equal to standard deviation over the mean value times 100%. Now let's have an example. Find the coefficient of variation of the given data below. So merong tatlong section dito, section A, section B, section C, and ito yung mga scores ng students. And dito sa baba, ito yung mean. Ang mean ng section A is, mean nilang tatlo pala. Ang mean nilang tatlo is 18.25 and ang standard deviation ng section A is 5.15 and ang standard deviation ng section B is 6.92 at ang standard deviation ng section C is 7.63. So, kunin natin yung coefficient of variation nilang tatlo. First is the coefficient of variation of section A. So, gamit yung formula as standard deviation over the mean value times 100%. So, ang standard deviation ng section A is 5.15 and ang mean value is 18.25 and multiply mo sa 100%, that would be equal to 28.22%. And sa section B naman, 6.92 yung standard deviation niya and mean, pareho lang yan sila, 18.25. So kung i-simplify mo yan siya, ang answer is 37.92%. And sa section C naman, 7.63 over 18.25 times 100% is equal to 41.81%. So analysis. So the score in section A are less scattered than the scores in section B and section C. In other words, scores in section A are more homogeneous than the scores and in section B and section C. Kasi, ibig sabihin, itong section A, yung mga score nila is parang magkakalapit lang. Wala masyadong difference. Kasi yung coefficient of variation niya, siya yung may pinakamaliit na value. And pwede naman natin sabihin na, or pwede natin i-interpret na, the scores in section C are more spread out than the scores in section A and section B. Or the score in section C are more heterogeneous than the scores in section A and section B. So, since ang section C ang may pinakamalaking coefficient of variation, ibig sabihin yung mga scores nila is magkakalayo yung agwat. Like, kita natin dito sa table, 'di ba? Ang dito sa baba is 30, 26, 26, 26, 26, while sa other half niya is 12 and 13. So, masyadong malayo yung difference, kaya siya parang mas scattered. So, next is the measure of skewness. So what is measure of skewness? So the measure of skewness, it is described the degree of departure of the scores from symmetry. Skewness coefficient or SK can be solved using the formula SK is equal to 3 times the quantity of mean value minus the median value all over standard deviation. So, itong skewness, para siyang, isa siyang graph. Makikita nyo din after. So, skewness can be classified according to the skewness coefficient. So, if the skewness coefficient is greater than 0, it is called positively skewed distribution. Kapag less than 0 naman, it is called negatively skewed distribution. If it's equal to 0, then it is normally distributed. So ito po yung skew na sinasabi, itong graph niya. Yung parang pa-curve, yun po yung skew. So, positively skewed or skewed to the right. So, ito po yung graph ng positively skewed or skewed to the right. So, the positively skewed or skewed to the right is a distribution where the thin tail of the graph goes to the right part of the curve. So, makikita nyo dito sa ating graph, ang tail niya, yung pinakamababa na part, is nasa right side ng mean. And this happens when most of the scores of the students are below the mean. Yung mean, yun yung average niya, right? And mapapansin nyo sa graph, yung may pinakamadaming, kumbaga, score is nandoon sa negative side ng mean. So, ibig sabihin, nasa negative side siya. So, ibig sabihin, hindi maganda yung performance ng mga students. So, in a classroom testing, a positively skewed distribution means that the student who took the examination did very poor. Most of the students got a very low score and few students got a high score. So, yun yung sinabi ko kanina, na kapag positively skewed, mas madami ang score sa negative side kaysa sa positive side. Kasi yung mean, yan yung gitna. And yung sa right side ng mean is yung mga positive 1 pataas. And sa left side niya naman is ang negative. And mapapansin nyo, yung scores nila is nasa negative side lahat. So, ibig sabihin, konti lang yung nakakuha ng mataas na score and mostly mga mababa na. Next is the negatively skewed or skewed to the left. Ito naman yung graphing niya. So, a distribution where the thin tail of the graph goes to the left part of the curve. So, kung yung positively skewed nasa right side yung thin tail niya, dito naman sa negatively skewed nasa left side. And this happens when most of the scores of the students are above the mean. So, diba, ang gitna ng mean and yung median and mode natin is nasa right side ng mean. So, anong ibig sabihin nito? So, for example, in a classroom testing, a negatively skewed distribution means that the student who took the examination performed well. Most of the scores are high and there are only few low scores. Kasi, di ba dito sa graph, di ba yung mode, yan yung may pinakamataas na score. And yung median is yung middle score. So, di ba mapapansin nyo, mas madami yung nakakuha ng mataas na score kasi nasa positive side siya. So, for example, find the coefficient of skewness of the scores of 40 grade 6 pupils in a 100-item test in mathematics if the mean is 82 and the median is 90 with standard deviation of 15. So, ang given natin, mean is equal to 82, and ang median is 90 and ang standard deviation is 15. So, using the formula, coefficient of skewness is equal to 3 times the quantity of mean minus median all over standard deviation. So, substitute lang natin yung value, magiging 3 times the quantity of 82 minus 90 all over 15. So, simplifying, 82 minus 90 is equal to negative 8. And 3 times negative 8 is negative 24. Then, negative 24 over 15 is equal to negative 1.60. So, analysis, the skewness is equal to negative 1.60. So, the value of skewness is negative, meaning the score distribution is negatively skewed. Most of the scores are high. This means that the students have performed excellently in the said examination. Now, let's have example 2. Find the coefficient of skewness of the scores of 45 grade 6 pupils in a 50 50 item test in biology if the mean is 46 and the median is 40 with standard deviation of 7.5. So, ang mean natin is 46, ang median natin is 40, and ang standard deviation natin is 7.5. So, substitute lang natin ulit using the skewness formula. So, magiging 3 times the quantity of 46 minus 40 all over 7.5. Pan-simplify natin yung nasa loob ng parenthesis. 46 minus 40 is equal to 6. And 3 times 6 is equal to 18. 18 over 7.5 is equal to 2.40. So, positive yung coefficient of skewness niya. So, the value of coefficient of skewness is positive, meaning the score distribution is positively skewed. So, most of the scores are below the mean. This means that the students have not performed well in the said examination. Now, let's have the normal distribution. So, properties of normal distribution. By the way, ito po yung graph ng normal distribution. So, ang mean, ang median, and ang mode is equal. Yeah, so the curve has a single peak, meaning the distribution is unimodal. So, peak ito yung pinakatuktok, 'di ba? Isang curve lang siya, isang curve lang siya kaya siya unimodal. So, from the word uni, one lang siya. Next is it is a bell-shaped curve. So, mapapansin nyo sa shape niya, it looks like a bell. So, next, it is symmetrical to the mean. So, yeah, ito yung toong symbol na to sa baba, yung tatlong X. Yan yung symmetric sila, equal lang. So, yung mean, yung mode, and yung median is equal lang. Next, the endtails of the curve can be extended indefinitely in both side and asymptotic to the horizontal line. So, makikita nyo, dalawa yung tail niya. And yung tail niya is, pwede siyang ma-extend indefinitely. Next is, the shape of the curve will depend on the value of the mean and standard deviation. Kasi, nakadepende sa mean and standard deviation kung gaano siya mataas ba siya, manipis, or malapad, something ganyan. Pero, bell-shaped pa din siya. And equal pa din yung both sides niya. And the total area of the curve is 1. Hence, the area of the curve in each side of the mean is 0.5. So, kung kunin mo itong area nitong curve, yung nasa loob, is 1 yung area niyan. And diba mapapansin nyo sa graph na hati siya sa gitna. Yung gitna, yan yung mean. And yung sa left side ng mean, ang area niyan is 0.5 and ang right side niya naman is 0.5 for a total of 1. So, the probability between two given points in the curve is equal to the area between 2 points. So, equal lang siya. So, areas under the normal curve. So, ito po yung area niya. So, hinati siya into, ilan ba ito? 8. 1, 2, 3, 4, 5, 6, 7, 8. So, ito yung area niya. By the way, itong sa baba, di ba merong mean, negative 1s, negative 2s, negative 3s, negative 1, positive 1s, positive 2s, and positive 3s. Yan yung standard deviation. So, 1 unit lang yung difference nila. So, yeah, ito yung area niya, and kung i-add mo siya lahat, itong 0.13, yung dalawang 0.13, dalawang 2.14, dalawang 13.59, and dalawang 34.13, ang equal niya is 99.98%. So, kita dito sa gilid, yung baseline niya yung nasa baba, and merong 3s units above and 3s units below. Ang 3s units above, yan yung positive, yung positive 1s, positive 2s, and positive 3s. And yung 3 units below naman is yung negative 1s, negative 2s, and negative 3s. And kung i-add mo yan silang lahat, kunin mo yung area nila is 99.98%. Now, a score distribution with mean of 74 and standard deviation of 4 using the normal curve model is about 34.13% of the scores in the distribution. Falls between 74 and 78 as shown in the given illustration. So, di ba, kanina yung unang pinakita. Yung 34.13%, same siya sa 74 and 78, and that's yun na yung 34.13%. So dito sa illustration natin, ang mean natin, itong nasa gitna is 74 and ang standard deviation is 4. Na paano mo nalaman na 4 yung standard deviation? Kasi when you look at the numbers below, yung 58, 62, 63, 70, diba? Yes, ang difference nila is 4. Kapag sinabi natin, diba yung kanina plus S, positive 1S, positive 2S, positive 3S, diba? Meron yun, tapos minus. Yung S doon is yung standard deviation. So, 74 and 78, ano ang difference nila, diba? 4. So, ibig sabihin, mag-add ka ng 4 sa right side and mag-minus ka ng 4 sa left side. So, 74 plus 4 is 78, plus 482, plus 486, plus 490. And sa left side naman is mag-minus ka ng 4. So, 74 minus 470, minus 466, minus 462, and minus 4 is 58. So, this is approximately equal to 68.26 or 68% of the score in the distribution fall between 72 and 78 as shown in the following figures. So, yung naka-shade, kung i-total mo yan siya, it is 68.26 or 68% kung i-round up mo siya, because 34.13% plus 34.13% is equal to 62.26%. I-add mo yan siya. Ganyan yung gawin. I-add lang siya ng i-add. So, ito siya. Itong figure na ito, it's about 95.44%. Ang mga students na nakakuha from 66.82 is nasa 95.44%, o pwede natin sabihin 95%. And ang nakakuha naman ng 74 to 82 rather is, ilan ba yan? 34.13% plus 13.59, it's about 47.72% or 48% of the student. So 48% of the student got the score from 74 to 82. Next is describing individual performance. Standard scores. So dito natin i-discuss ang different kinds of converted scores. So, the procedures for converting raw score to standard score are presented in the section. I-discuss ko din siya. So, there are four types of standard score, which are the Z-scores, T-scores, standard nines or stan nines, and percentile ranks. So, scores directly obtained from the test are known as actual scores or raw scores. Yung mga scores mismo ng mga estudyante na nakukuha sa isang test, yan yung tinatawag nating actual scores or raw score. So, such scores cannot be interpreted as whether the score is low, average, or high. So, kung i-base mo lang siya doon sa mismo score, hindi natin siya masasabi na yung score ba na yun is mataas ba or mababa. Kaya gagamitan natin siya itong types of standard scores. So, kaya ang gagawin natin, i-convert natin siya or i-transform natin siya so that they become meaningful and allow some kind of interpretation and direct comparisons of two scores. So, consider mo itong dalawang figure na nandito. Diba same lang yung shape ng nila, same lang yung shape ng skewness nila, pero kung titingnan mo sa baba is magkakaiba yung scores. So figure A represents the score distribution with a mean of 50 with a standard deviation of 10, kasi when you look at here, diba 50, tapos may isang line, dalawang line, then 80. So, 50, 60, 70, 80. So, ang difference nila is 10. Kaya ang standard deviation nila is 10. And sa figure B naman, represents a score distribution with a mean of 80 and standard deviation of 5. So the shape of the two score distribution above is the same, yun nga, magkapareho lang, pero this means that the means and the standard deviation are different. So this happens because the ranges of the score from figure A differ from figure B. In this case, the scores in those figures cannot be compared because they belong to two different groups. So, hindi mo sila pwedeng ma-compare na mas mataas ba yung isa kaysa sa isa kasi from the start naman is hindi sila same ng kinuha ng group. Magkaiba sila ng group. So, let's have an example. Rich Glenn obtained a score of 92 in business calculus and 88 in production management. In which subject did he perform well? Di natin masasabi kung alin nga ba yung mas mataas yung subject na magaling siya, kung sa business calculus ba na meron siyang 92 or production management na 88. Kasi, pag sinabi nating mas magaling siya sa business calculus, then we are treating 92 as percentages. And in most cases, scores are converted to percentages before the teacher return the test papers to students. Pero, hindi naman always. Kasi, di ba meron yung mapansin nyo kapag perfect ka, di ba? 10 out of 10. Pwede nila, tapos sa gilid nun, di ba merong 100%. Di ba may mga ganon, merong 75%, may 50%. Di ba ganon yung minsan binibigay ng teacher nila. And Rich Glenn's score of 92 in business calculus might mean that he answered 92 in a 100 item quiz, or pwede namang 92 out of 95 or 92 out of 200. So, hindi natin masasabi kasi first of all, hindi natin alam kung ilang items hindi natin alam kung ilang items ang meron yung subject na yun. Same dito sa production management, hindi din natin masasabi na mataas ba yung 88 or mababa kasi hindi din natin alam kung ilang items yung meron doon. So, kaya natin siya gagamitan ng standard scores. In other words, raw scores cannot be interpreted directly, so we need additional information about the scores in the distribution. So, hindi natin siya makuha unless may iba pa tayong information about doon. So, the raw scores of all students in the business calculus and production management are very important so that we can get the information that describes both score distribution. Based from our previous discussion, so, based doon sa na-discuss ng kagroup ko, the mean value and the standard deviation are necessary to describe the distribution of the score. So, kung gaano siyang ka-scattered, ganon. So, let us add the mean values and the standard deviation of the scores of students in business calculus and production management as shown. So, for example lang ito ha. Yung business calculus, ang mean niya is 95. Ang raw score ni Glenn is 92 and ang standard deviation is 93 because yan. And sa production management naman, sabihin natin ang mean is 80 and ang raw score niya, 'di ba, is 88 and ang standard deviation is 4. Rich Glenn's score in business calculus is 3 points below the class means performance and 8 points above the class means performance in production management. So using the mean value, we can say that Rich Glenn performed better in production management than in business calculus compared with the performance of the rest of his classmates. So, ang score ni Rich Glenn dito sa business calculus is mas mababa kesa sa mean. So, kung i-graph mo siya doon sa yung graph mo siya, ang maging kalabasan niya is positively skewed, 'di ba? So ang score niya mas mababa sa mean, ibig sabihin negative. So dito naman sa production management, mas mataas yung score niya kaysa sa mean. So ibig sabihin, pwede nating masabi na mas maganda yung performance niya dito sa production management. Gamit lang yung mean value, pwede nating masasabi na mas mataas yung performance niya or mas maganda yung performance niya sa production management. Pero paano naman kung sa standard deviation? Hindi ba ang standard deviation enables us to know how many percent of the scores above or below each score has in the distribution. So, assuming that the scores on business, calculus, and production management are normally distributed, assume natin na normal lang siya. Let us construct a curve that represents the given data. So, ito yan siya. Ito yung sa business calculus and ito yung sa production management. Kasi ang normal distribution is the normal curve model is used as a basis to compare the distribution with different means and different standard deviation. So, kaya gagamit tayo ng normal curve. The shaded area represents the percentage of the scores lower than the score of Rich Glenn. Itong naka-shaded area, di ba sa business calculus, ang grade niya is 92. So, ang mas mababa sa kanya, yung naka-shade ng blue. And dito sa production management, ang score niya is 88. And yun yung mas mababa. Yung naka-shade, yun yung mas mababa sa kanya. So, kung ikuan mo yan siya, i-add mo yung mga percentage, yung 0.13 rather, percent, 2.14, and 13.59. Kung i-add mo yun siya, kung i-total mo yun siya, it's 15.86% or approximately 60% of the score below the score of Rich Glenn in business calculus. Or his score is 16th percentile. And yung sa isa naman, sa production management, kung ikunin mo yung area, yung naka-shade niyan, it's 97.71% or approximately 98% of the students score in production management are lower. Yan yung mas mababa sa kanya. So, dito sa production management, ang percentage ng classmates niya, kumbaga, na mas mababa sa kanya is 97.71% or approximately 98%. Then, si Glenn is nasa 98th percentile. Yung score niya is nasa 98th percentile. So, mas mataas yung score niya sa production management kaysa doon sa business calculus. Next is Z-score. The Z-score is used to convert a raw score to standard score to determine how far a raw score lies from the mean in standard deviation units. From this, we can also determine whether an individual student performed well in the examination compared to the performance of the whole class. So, itong Z-score is isang way para malaman natin kung gaano ba kalayo yung score natin sa mean score. And the Z-score value indicates the distance between the given raw score and the mean value in units of the standard deviation. The Z value, yung Z-score, is positive when the raw score is above the mean. Kapag nasa right side yung raw score mo, ibig sabihin positive yung Z-score mo. And kung nasa left side naman siya, then it is negative. So, the formula of Z-score is Z is equal to the raw score minus the mu or the population mean all over the population standard deviation, or pwede natin sabihin, or another way rather, kasi diba sa isa is population, dito naman kapag mean lang yung, sample mean lang yung binigay, pwede natin gamitin ang formula na raw score minus the sample mean all over sample standard deviation. So, example natin kanina, ulitin natin. Using the data about Ritz-Glen score in business calculus and production management, pwede natin ma-solve. So, diba, sa business calculus, ang mean niya is 95, ang raw score niya is 92, ang standard deviation is 3. So, using the formula, substitute lang natin. So, 92 minus 95, it is negative 3 over 3. And negative 3 over 3 is negative 1. And sa production naman, 88 minus 80 is 8 all over 4. It is 2. So, the score of Ritz-Glen in business calculus is 1 unit standard deviation below the mean. And his score in production management is 2 unit standard deviation above the mean. Therefore, we can conclude that Ritz-Glen performed better in production management than in business calculus. Kasi kung i-compare mo nga, sa production management, positive 2 yung z-score niya, and sa business calculus is negative 1. Next naman is ang t-score. So, t-score is another type of standard score where the mean is 50 and the standard deviation is 10. Sa z-score, di ba ang mean niya is 0, tapos yung standard deviation niya is 1. While dito naman sa t-score, ang mean niya is 50 and ang standard deviation niya is 10. And to convert raw score to t-score, find the z-score equivalent of the raw score and use the formula. So, itong z, yan na yung z-score. So, t-score is equal to 10 z-score plus 50. Solve natin sa business calculus. Diba negative 1 yung z-score na na-solve natin kanina? So, substitute lang siya natin. So, 10 times negative 1 plus 50. 10 times negative 1 is equal to negative 10. And negative 10 plus 50 is equal to 40. And doon sa production management, ang z-score is positive 2. So, substitute lang natin. So, 10 times 2 is 20. And 20 plus 50 is equal to z-score of negative 1. Itong business calculus is equivalent to a t-score of 70. And the negative value is eliminated in the t-score equivalent. Therefore, Ritz-Glen performed better in production management than in business calculus due to higher value of t-score, which is equal to 70. So, sa production management, 70 yung t-score niya, and sa business calculus, 40. So, ibig sabihin, mas better talaga yung performance niya dito sa production management. And ito po yung, kung i-compare natin, ito yung relationship between t-score and z-score. So, diba, sabi ko kanina, based sa illustration natin, ang mean ng z-score is 0 and ang standard deviation niya is 1 unit. Kasi diba, when you look at the difference between units, 1, 2, 3, so 1 lang yung difference nila. And dito sa t-score naman, ang mean niya is 50 and ang standard deviation niya is 10 because diba, 10, 20, 30, 40, 50, 60, ganon. So, that's all po for my report. I hope na naintindihan nyo kung ano yung t-score, z-score, and yung coefficient of deviation. So, that would be all. Thank you.